Hi, this is a video on the intermediate value theorem, which is something that you need to be familiar with, and it's a very important theorem in algebra. So what does it say formally? It says if f is a continuous function on an interval a to b, a closed interval, for some value n that's located between the value of the function that corresponds to the endpoint, so f of a and f of b, the value of n is located between them, there will exist a value of c where f of c is going to equal n. In other words, if you pick a value of n on the the y-axis between the values of f of a and f of b, you will have at least one value of c that's going to fall on the interval from a to b, where the value of the function will equal to the value of n. In plain terms, as you go from a to b on the x-axis, f of x is guaranteed to hit every value between f of a and f of b at least once, as long as the function is continuous. This is what the graph looks like. So we have our a, the b, so this value here is f of b, that should actually be f of a, and this one should be f of b. Okay, and so this point here corresponds to that. So we're picking some value of n that's between a and b, and we trace across, and we see that there is a point that corresponds to some value of c, and that value of c lies between a and b. Okay? So this theorem is important because you do have a required condition that the function must be continuous, because if the function is not continuous somewhere on the interval, then you cannot apply the intermediate value theorem. Let's take a look at an example. Consider f of x equals 3x minus 2. Does the intermediate value theorem guarantee that there is x equals c on the interval from 2 to 6, where f of c is going to equal 10? Here's what you need to do. You're going to need to find f of 2. This is one endpoint. Well, I'm going to get to it. So 3 times 2 is 6, 6 minus 2 is 4. Then we're going to need to find f of 6. So that's 6 plugged in here. 18 minus 2 is 16. F of x, we know it's a continuous function, it's a linear function. So for sure it's continuous on the interval from 2 to 6. And since 10 lies between 16, well, let me write it this way, f of 6, which is 16, and on the other side it lies between f of 2, which is 4. So then yes, it is guaranteed. Okay. Because we have a continuous function, we have two values. The value that we're interested in for f of c lies between these two values. That means that there will be a value on the interval from 2 to 6 where the value of f is going to equal 10. Let's consider this next problem. This function here, does the intermediate value theorem guarantee that there is a point on the interval from 0 to 3 where f of c is going to equal -1? Let's find out. So first of all, we know that f of x is continuous. It's a quadratic function, so it will be continuous on the interval from 0 to 3 for sure. F of 0 is 1. F of 3, what is f of 3? Let's see, we'll plug in 3 in here. That's -9 plus 6, which is 3. That's 1, that's 4. Right? No, I'm sorry, -9 plus 3 is -9 plus 6 is -3 plus 1 is -2, so this is -2. So since, what do we have here? This value here, -1, is going to lie between these two numbers. So since f of 0, which equals 1, well, actually we have to turn it the other way. Well, I can turn it I have a way to do that, is going to be greater than or equal to -1, which is going to be greater than or equal to -2, which is the value of 3. So we have a value that's trapped between them. The function is continuous, therefore there exists such C. Okay. Example 3. So we have this function f of x, and does the intermediate value theorem guarantee that we have a value on the interval from 1 to 3 where f of c is going to be 4. So we know this is a continuous function, so f of x is continuous. This is a required condition. You cannot apply the intermediate value theorem if the function is not continuous on the interval from 1 to 3. And we know that f of 1 is going to equal, that's 1 minus 2, that's -1. F of 3 is 9 minus 6, which is 3. And we have a slight problem here, because this value of 4 does not fall on this interval. And that means what? That does not mean that there's no such value. That just means that we don't know. And the intermediate value theorem cannot guarantee such number. So we say cannot be guaranteed. Okay. As a matter of fact, there is no such value on that particular interval for that particular function, but that does not mean it's not going to happen in general. Let's consider this function. So f of x is not continuous at x equals 1. And the problem is that 1 falls on the interval from 0 to 2. And that means that you cannot use the intermediate value theorem, because the function must be continuous on the entire interval. And since we have at least one point where the function does not have continuity, then you cannot apply it. The theorem does not apply. But I do want to show you one interesting thing about this problem. This is basically the answer here. If you forget about analyzing continuity and actually try to find f of 0, you will get -3. And when you try to find f of 2, you will get 7. And then you're going to look probably at this value and say, oh look, 5 lies between -3 and 7, so there is such number. We don't know that. Maybe there is. As a matter of fact, there is. But the problem is that since the function is not continuous, it's not going to apply. I'll keep that in mind. Alright, an application problem. A rock is thrown in the air. Its velocity is given to us by this function. Show that there exists time on the interval from 1 to 7 where the velocity is going to be 110. We see that this is a continuous function. On the interval from 1 to 7, it's continuous everywhere. And then we can say v of 1 is going to be what? 320 minus 32, right? So it's going to be 320 minus 32, which is 288. V of 7 is going to be, so it's 320 minus 32 times 7, which is going to be 96. Right? So 110 lies between these two numbers, correct? 110 is going to be less than or equal to 288, which is v of 1. And on the other side, it's greater than 96, which is v of 7. Such value exists. There's a couple more things I want to show you. First of all, what does at least once mean? That means when we pick a value on the interval from f of a to f of b, that means that if the function is continuous, there's guaranteed to be at least one point on the interval from a to b where that value is going to be attained. But that means there's at least one. You can have multiple. Like in this case, for that particular value of n that I picked, I have 3 points where such thing is going to happen, where we're going to attain this value, and all 3 points are going to fall on that interval. So when it says at least ones, it means that is guaranteed 1 and potentially more. Right, last thing that I want to show you here, there's a very important implication of the intermediate value theorem when it comes to finding zeros of a function in a closed interval. If you have a continuous function and the value of the function at the endpoints is going to be up, like you are going to have opposite signs, so positive on one side, negative on the other side, or vice versa, then you guarantee that it's going to have at least 1 0 on that interval. In other words, the function must cross the x-axis at least once. And then the question is, does the intermediate value theorem guarantee that f of x equals x squared minus 2 have at least 1 0 on the interval from 1 to 2? Let's find out. F of 1 is going to be negative 1. F of 2 is going to be 4 minus 2, 2. 1's negative, 1's positive. Yes, it has at least 1 0. Okay. What do you do? Back in the days when calculators did not exist, the approach for finding zeros, for approximating zeros for functions that you cannot easily solve, especially was the case with polynomial functions, here's what you do. So we know the function here is going to be at negative 1, and here it's at 2, so it crosses the x-axis, something like this. This is 1, this is 2, right? So then the process was, you divide the interval in half, and you say, okay, what happens now? So on this end it's negative, on this end it's positive. Then you're going to take the next, this interval, and divide that by 2. So now it's negative here, positive here. And this process could be continued until you're satisfied with the value that you're getting, until it's close enough. Okay? So this is how these problems were done before. And I hope this was a helpful lesson. We'll see you.